Hi guys, hope you are doing well, and I think you're watching all my previous videos. Today I'm going to teach you a small concept of ionization energy. You know the trends of the periodic table. This is one of the trends of the periodic table. Trends mean anything which is repeating when we move across the period and down the group. First of all, what is meant by the term ionization energy? Any idea? Ionization energy, it is the amount of the energy required or needed to take away an electron from one mole of a gaseous atom, of a neutral gaseous atom. I will explain you. First, let me write the definition of ionization energy. You can write IE also, ionization energy, IE. It is it is the amount of energy needed or required, needed to remove an electron from one mole of a neutral gaseous atom. Neutral gaseous atom. We are removing an electron from one mole of a neutral gaseous atom. We know that this side of the periodic table, we have all the metals, even the transition element or D black. Or, this side of the periodic table, we have metals, group 1, group 2, D block elements, all are metal. So I'm not talking about non-metals. The extreme right side of the periodic table, we have non-metals. Now, sodium is in the solid form. We know metal give away the electron. Sodium has to lose one electron. But how? Can it give away the electron by its own? Or we have to supply some amount of the energy so that the sodium can give away one electron. Solid state, sodium cannot give away any electron. What we have to do to take one electron, to knock one electron from the outer shell of the sodium. Look at that. Sodium has 11 electron, 11 proton, 11 electron, 11, 1s2, 2s2, 2p6, 3s1. So outer shell, it has one electron. It can give away that electron to get 8 electron in the next shell. And the shell which is just below the outer shell has 8 electron. 1, 2, 3, 4, 5, 6, 7, 8. We know ionic bond is formed by the loss of electron from the metal and gain of electron from the gain of electron by the non-metal. But think about it, how can a metal give away the electron? By its own, what should we have to do so that that sodium loses this outer electron? First of all, we cannot take away the electron from the solid metal. Then what we have to do? Solid metal change to a gaseous form, Na gas. This state, conversion of the solid form to liquid form, is called sublimation state or sublimation. Sublimation is, sorry guys, my bad. Sublimation is a physical process where solid form of metal or non-metal, anything, converted into gaseous form. Then this sodium give away one electron and form Na plus ion. Here to here, this is called sublimation energy, but we are not using sublimation energy, we are using enthalpy of atomization. When I will teach you Born-Haber cycle or Hess's law to figure out the lattice enthalpy, I will tell you. So delta H, atomization energy. Enthalpy of atomization is the amount of energy needed to change a solid state to a gaseous form. And after that, it gives away the electron. Can it give away the electron by its own? No. We need some amount of energy. That energy is called ionization energy. So ionization energy, it is a type of the energy needed or required to remove an electron from 1 mole of a neutral gaseous atom. From here to here, solid to gas form, sublimation energy or enthalpy of atomization. From gas form to become anion, the energy needed is ionization energy. It is an endothermic process. Endothermic process. This is an endothermic. Endothermic process. Endothermic process meaning we are supplying some energy so that the sodium can give away the electron. Okay. We know metal lost electron and non-metal gain electron. So what we are looking how this ionization energy changes down the group and across the period. Now we know what is meant by the term ionization energy. Next thing, what are the factors which affects the ionization energy? Meaning, some factors, whether you move across the period or down the group, that affects the ionization energy. What are they? What are the factors that affecting the ionization energy? Factors that affects IE values. Any idea? First one is atomic size or atomic radius. We will see what happened to the atomic size or atomic radius across the period or down the group. Atomic size or atomic radius. Both are fine. Atomic size. First factor, atomic size. Atomic radius. 1. Second factor, nuclear charge. Some teacher use the term average nuclear charge. Don't worry about it. I will explain you what is the meaning of average nuclear charge. But nuclear charge is important. Third one is shielding effect. Shielding effect. First of all, we will see how these vary across the period and down the group. So what are the factors that affects ionization energy? Atomic radius or atomic size, atomic radius or atomic size. Atomic or radius, same thing. Then we will see the trends of atomic radius down the group across the period and how atomic radius alter the ionization energy, whether it will increase the ionization energy or decrease the ionization energy. Same thing we will see nuclear charge. And after that, we will see what is the effect of shielding on the ionization energy. Apart from that, you have successive ionization energy like IE1, IE2, IE3. When you are continuously removing the electron from any metal, what happened to their values, whether they are increasing or decreasing, we will see that one. And we are comparing ionization energy of the group 2 metals and group 3 metals and group 5 and group 6 non-metals. Okay. Now, first thing, atomic radius. We will see how the atomic radius increase or decrease when we move down the group and when we go across the period. Atomic radius. When we are going down the group, atomic radius increases. Why? Due to increase in number of shells. When you go down the group, obviously number of shell increases. When the number of shell increases, the distance between the radius or the distance between the nucleus and the outer shell electron increases. That's called atomic radius. So atomic radius, first we will do down the group, atomic radius down the group, and atomic radius across the period. Now, look at that. Lithium, sodium, potassium, rubidium, cesium, francium. We have hydrogen, 1H1. These are called periods. We have 7 periods. 1, 2, 3, 4, 5, 6, 7. 7 period means 7 shell. Hydrogen has 1 shell. Lithium has 2 shell. So lithium nucleus, 1 shell and 2nd shell. When you compare to francium, it has 7 shells or energy level. Look at that. 2, 3, 4, 5, 6, 7. Look at the size. When you go down the group, the atomic radius, this, or atomic size increases. Why? Due to increase in number of shells. Atomic radius increases down the group due to increase in number of shells. Look at the distance. So look at the electron here and look at the electron here. You can guess what happened to ionization energy when we move down the group. So atomic radius increases when we move down the group. Let's see what happened to the atomic radius when we move across the period. Now look at the atomic radius across the period. So atomic size or radius, atomic radius across the period. Across the period, we have lithium 3. We have lithium, boron 4. That's the number of electron. Lithium boron. Sorry, lithium beryllium. We have hydrogen 1H1, helium 2H4, 2 electron, lithium 3 electron, beryllium, boron 5 electron, carbon 6 electron, nitrogen 7 electron, oxygen 8 electron, then we have fluorine 9 electron, neon 10 electron. Neon should be here, guys. So helium and neon are in 0 group or 8 group. This is called 8 group element or 0 group element. Why they are called 0 group? The outer shell of these elements are completely filled. They are not easily participating in any chemical bond, and the ionization energy of these elements are highest when we move across the period. Let's see how the trends of ionization energy changes. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and a neon 10 electron. When you move across the period, the number of the shells are same, the number of energy levels are same. Oh, so we didn't get it. No problem. Look at the diagram. Look at this picture. So boron, lithium has 3 electron. 1s2, 2s1, 2s2, 2s2, 1s2, 2s2, 2p1, total 5, 2p2, 2p3. P orbital can have maximum 6 electron. 2p4, 2p5, 2p6. Look at the number of shells. That's my first energy level. That's the second energy level. Your main energy level is 2. Look, main energy level is 2, 2, 2, 2, 2, 2. But what happened? When we move across the period, size stays the same. There is no increase or decrease in the size. But when you go across the period, number of the electron, 3, or which has same number of proton, increases. As a result, all these electrons or proton move towards the nucleus. They're moving towards the nucleus. So the force of attraction increases. Size, no doubt, most of the students are getting confused with this size. Size stays the same, but that will affect the nuclear charge. I will tell you what is meant by the term nuclear charge. So when you move across the period, how many shells? 2 shells. Shells are same, number of shells are same, but the number of protons or electron increases. Mean the space is decreasing between the nucleus and the outermost shell, but the total number of shells are same. So can we say the atomic radius or the atomic size across the period stays same? No effect, but these electron create some impact on the nucleus. We will see in the nuclear chart. So the atomic size, atomic radius across the period, stays same, no change. Now, second point is nuclear charge. First of all, what is meant by the term nuclear charge? I have seen many past paper and the examiner will not ask you what is meant by the term nuclear charge. The question will come how that nuclear charge has an impact on the ionization energy. We will see that one. But before that, what is meant by the term nuclear charge? The students have this type of question. So what is actually meant by the term nuclear charge? Let's see what is meant by the term nuclear charge. Can I rub the board? Let's see. So we will discuss the second highlighted point, this highlighted term, nuclear charge. Now, nuclear charge. What is meant by the term nuclear charge? Nuclear charge? Nuclear charge. Look at this nucleus. Take any element in the periodic table and look at this. That's the nucleus, and you have all these electrons. Suppose I want to take nitrogen. Like nitrogen has 7 electrons. 1s2, 2s2, 2p3. So first shell 2 electron, second shell 2 electron, and a p has, so it has p, and a p has 3 electron. 1, 2, 3. So look at the distance, or I'm using the different marker. The distance between the nucleus, and the outer shell electron, that's the nuclear charge. It is a force of attraction because electrons are negatively charged particle, and inside the nucleus we have proton which are positively charged particle. So it's a force of attraction between the nucleus and the outer shell electron. So it is a force of attraction. It is a force of attraction between it. It is a force of attraction between nucleus and outer shell electrons. That is called nuclear charge or effective nuclear charge. Same, a slight difference between the effective nuclear charge or average nuclear charge and the nuclear charge. Don't worry about it. When I will teach you when I will make some videos only on the periodic table. So between it is the force of attraction between this nucleus and the outer shell electron. So that force of attraction increases when the atomic size decreases or when the electrons are moving close to the nucleus. Just now we have seen when you go across the period, we have same number of shell, but the number of protons or electron decreases. What happened when we move across the period? Look at it. Across the period, number of shells, what happened to the number of shells? Same. Number of shells are same. But when we move down the group, number of shells increases or outer shells increases or the distance between the nucleus and the outer shell increases. Here, number of shells are same. Across the period, number of the shells are same. But what happened? Number of the electron increases and they are present in the same shell. When they will ask you how the nuclear charge affect the ionization energy, you have to mention all these points, guys. So what happened? Number of electrons increases in the are increased in the same shell. So what happened? When the number of electron increases in the same shell, there's more force of attraction. And these electrons try to move towards the nucleus. That's called the nuclear charge. How that nuclear charge affect the ionization energy, or what is the impact of all these factors on the ionization energy, I will teach you in my next lesson. I will discuss all these factors in my next lesson. I want to stop here. Thanks for watching my videos. We will come back soon.